I used to think that you'd have to string together a whole bunch of narrow AIs, and then you'd have a supervisory one that would then take all that information and, give you the answer. And then I thought, okay, well, that's not how it works today. But then what if we add that in? So you have an AI that's listening to our conversation, me and the doctor, and it's using this huge broad base of knowledge. But is there any point for that AI to spin up a series of narrow AIs to analyze subunits of the problem and then take that as another signal of data to make it even better picture, or would that skew it the wrong way?
No, you're hitting on a very, very, very important area. So that general model that might be able to take that transcript and write a note, it may do pretty well. But you could further train it on that task to make it even better at that task with examples like we talked about with the narrow AI days. You can do that same thing even with that big giant model. You can train it on here's a transcript and here's the final note. And what you call it, that's called fine tuning, right? So that's one way to address any gaps in the performance of the model itself. But to your point about narrow models, it doesn't mean that all the narrow models that we've built over the years are obsolete. And when you hear these things, maybe in the popular press, people talking about agents, you have a general model that understands how to have a conversation with, you over text and understands the situation. If you said, hey, I need you to look at this chest x-ray, it might go and run the image through one of those narrow models, to your point, and then bring that information back to me. And that's kind of this agentic, that's when you start thinking about these agentic tasks. So turning the model in from a one-to-one interaction to it's using tools like it's searching on the internet, or to your point, it's going through several steps and realizing I have to use a calculator, or I have to use a different model to get the answer on this particular point. And then I'm going to come back and I'm going to pull all that information together and give it back to you. And that, if you've ever used deep research.
Yeah. The only thing I didn't like is at the time I couldn't pause it and I didn't want to wait 15 minutes and watch the results and be like, oh, wait a minute, that's wrong, shit. And then redo the whole thing over and over and over.
I have heard that. Yes, I have heard that too. Yes, it's kind of like you send off someone on an errand. You're like, wait, no, I also need milk from the store. Shoot, you're already gone a half hour before you come back.
What about a supervisory model? Now it uses narrow AIs. It also uses the general one, but then it looks at the results and it controls the fine tuning so that you don't overtune. And maybe another supervisory one that looks at the data you're pulling and make sure, like, I don't know, if the data is not poisoned or skewed in some way. Like, it sounds like you could add in a bunch of like quality assurance type models and, run it using different models. Like what if you put into, I don't know, maybe a crude example, it's a ChatGPT and you run every model they have, and then you compare the results and you pick the one that seems to be the most relevant to the answer and then display that. It sounds like a lot of computing power, but I guess for really difficult problems, maybe you need to just throw everything at it. You get narrow AI, general AI, a fine tuning control process, module. I mean, all this stuff. I don't know if that makes sense.
No, it does. And there's a few concepts that you're hitting on, like it sounds like, just organically here, but these are very real. Exactly. So, if you think about a really complex problem in healthcare where you have like images and you have text and you need to figure out if that patient qualifies for clinical trials, and then you need to figure out what the research is, you have a series of tasks. To your point, you can have a supervisory model that you're interacting with. You say, hey, can you process this information and bring me back everything I'm going to need to know to take care of this patient? Well, it's going to set off a series of subtasks. And some of the subtasks, to your point, might be other models that have been prompted a different way or fine-tuned a different way, right? Some of them might be those narrow models we talked about. Some might be just organic search. But the idea that you also have about having a supervisory kind of checker is a very popular one. And again, yes, you would have to use a lot of compute, but the other factor that's going on in addition to the models getting smarter and smarter much more frequently is also that the cost is going down. So even some of those things that you're like, that's a little much, right? It would take too much compute or too much time or whatever it is. It's very rare that that's a barrier to trying something out, because we kind of anticipate cheaper, faster models anyway at the same level or better intelligence. But the last thing you mentioned, which is like provide several answers and then judge which one's most likely to be correct. That's something that you can even do with one model. You can have it answer it 10, 15, 100, 1,000 times and look at that distribution and say, it's saying this one answer way more often than the others. So this is probably the right answer, right? So there's all kinds of tricks like that. It's a fascinating area. Like there's thousands and thousands of papers just in the last couple of years, just on these kinds of thoughts and concepts.